Here's a scenario every front-end developer eventually encounters. A user types in a search box. Your app fires an API request for N, then no, then Nod, then Node. The user is fast. 4 requests are in flight simultaneously. They might come back out of order, Node might arrive before Nod. Your UI shows stale results, flickers, or shows the wrong state. Or imagine the user navigates away from the page entirely. Your fetch request is still in flight, and when it resolves, your callback tries to update state on a component that no longer exists. In React, this produces the dreaded warning, can't perform a React state update on an unmounted component. Both problems have the same root cause, JavaScript promises are not natively cancelable. Once you create a promise, you cannot tell it to stop. You cannot call promise.cancel. The underlying async operation, the network request, the timer, the file read, continues running even if you no longer care about its result. This is a deliberate design decision. Cancellation semantics are complex. What does it mean to cancel a promise that's halfway through? Should it reject? Resolve with undefined? Do nothing? The specification authors chose not to include it. But in practice, you need cancellation behavior all the time. Search as you type, page navigation, timeout handling, user-initiated abort. The good news is that the ecosystem has converged on clean patterns for implementing cancellation on top of the existing promise model. And Node.js now has a native solution, AbortController. Understanding how to get there from first principles makes you dangerous with any of these APIs. The simplest cancellation approach is a Boolean flag. You create a variable, let cancelled equals false. You fire the async operation. When it resolves, you check, if cancelled, do nothing. The caller can set cancelled to true at any point. This works, and it's what most developers reach for first. But it has a critical limitation, the underlying operation still runs to completion. If you cancel a search request with a Boolean flag, the network request still travels to the server still processes it, the response still comes back over the network. You just throw away the result. For expensive operations, this wastes server resources. The more principled approach is the AbortController API, which is available natively in browsers and in Node.js 15+. An AbortController instance has a signal property. You pass that signal to fetch or any other AbortController-aware API. When you call controller.abort, the fetch is actually cancelled at the network level. The server never receives the request, or if it's already in flight, the connection is closed. The AbortController pattern composes beautifully with React's useEffect cleanup function. When a component mounts, you create a controller. You pass the signal to fetch. When the component unmounts, which triggers the cleanup function, you call controller.abort. The in-flight request is cancelled. No stale state updates. No memory leaks. The book also covers a more exotic approach, using generator functions as cancelable async runners. A generator's ability to pause at yield points gives you natural insertion points for cancellation checks. You can build a wrapper that runs your async generator and stops it at any yield. This is similar to how RxJS cancels observable subscriptions. It's the same conceptual model, different syntax. For most applications, AbortController is the right tool. For complex orchestration with multiple concurrent async operations, something more structured may be appropriate. Let's anchor the theory in the concrete use cases where cancellation matters most, and look at the patterns that production applications actually use. Search as you type is the canonical example. Every keystroke fires a request. Only the most recent request's result should be displayed. The clean implementation, each time the input changes, cancel the previous AbortController and create a new one. Only the latest controller is active. When any earlier request comes back, it's already been aborted, the result is silently discarded at the network level. Page navigation in a single-page application requires cleaning up pending requests when the user navigates away. In React, this is the useEffect cleanup function. In Vue, it's the before-unmount lifecycle hook. In any framework, the pattern is the same: track your in-flight requests, cancel them all when the component or page is deactivated. Timeouts are a form of cancellation. If a request hasn't completed within n seconds, cancel it. With AbortController, this is a set timeout that calls abort. There's even a utility function in the fetch API abortSignal.timeout, milliseconds, that creates a signal that automatically aborts after the specified time. Concurrent operation management is the hardest case. You have multiple operations running in parallel, but you only want to use the result of whichever finishes first. Promise.race is the classic solution, but it doesn't cancel the losers. The correct implementation starts all operations, passes each one an abort controller signal, and when the winner resolves, calls abort on all the others' controllers. The theme across all these cases, cancellation, is about resource management. Network connections, server compute time, memory for buffered responses. Knowing how to cancel is a prerequisite for writing applications that behave well under real-world conditions.